Hi, good morning, everyone. Great to see you here bright and early on a Sunday morning. You could have done anything else like sleep in. Was it raining this morning? Yeah, but you're here, so that's awesome. Thank you so much for joining us. So I'm Deborah Anita. I'm the moderator for this panel called Getting Started with Zero Knowledge. The first session for, I think there's going to be a couple of other talks focused on zero knowledge, so I hope you stick around. A very quick intro. I'm a senior account manager at Yap Global. Yap Global is a PR, it's a public relations firm focused solely on crypto native projects. So we work with some decentralized finance projects and infrastructure. If you've heard of Lido, ENS, Nil Foundation, Manta Network, Gitcoin, a whole bunch. So we basically help our clients get into the media and get publicity. And I'm joined by our two speakers today. They're both from the Ethereum Foundation. I think Ethereum Foundation needs no introduction. We have Cece, who is a senior engineer at Privacy and Scaling Exploration team, and we've got One Sub, who is a researcher at Privacy and Scaling Explorations. Maybe you guys want to do a quick intro of yourselves?
Yeah, thanks, Ms. Deborah. I'm CC, and I've been in the crypto space for 5 years and building ZK circuit for almost 3 years, and we're building the ZK EVM these days.
Glad to be here. I'm Wansop, and I'm working as a researcher. Just recently looking at some programmable cryptographies, and yeah, happy to be here.
Thank you. Okay, quick question. Who has zero knowledge about zero knowledge? Hands up. Okay. So everyone else has above zero? 0.1, okay. Just want to get a quick sense of who's in the audience. If you are a developer in Web3, could I see hands? Okay, cool. Does everyone else work in Web3, or okay, students? Any students here? Okay, nice. Anyone who works in Web3 but not a developer, or maybe you're trading and okay, nice. So I think everyone's pretty familiar with, okay, everyone's familiar with Web3 topics in general. Okay, well, we're not gonna go so super deep. We're gonna touch on some high level topics because that's what the rest of the day is for. So we'll touch on, yeah, some high level themes, and maybe we can get straight into it. But first, to start off, can maybe one of you guys explain zero knowledge in a nutshell? What's your go-to to understand it?
Yeah, hopefully I get this one. So Zero-Knowledge, you can think it as a digital signature for computations. And for these computations, you don't have to reveal like every data in this computation. So you can hide important informations. You can build privacy applications and a lot of scaling applications with zero knowledge.
Yeah, and I can give a little bit more kind of theoretical some definition that zero knowledge proof is proving some relationship. So the most one simple example is your transaction signature, ECDSA, the elliptic curve signature. Actually, you are proving that you have a private key or the public key, and it's pretty short, right? So in ZKP, when the relation is too big, the proof actually also grows. But what we really would like to do is that, okay, we would like to keep the proof still small when you would like to prove a really big relationship. And also during proving the relationship, we should input some values, for example, your private key. And in the elliptic curve signature, you could hide your private key while revealing your own only the public key. And in ZKP, actually, we should be able to choose what kind of information you would hide while proving the relationship. Is there what the ZKP works. Was it simple or?
Yeah. Can you talk a little, just for the rest of the conversation, ZKP we'll just shorten zero knowledge to ZK, and the P is proof, so ZKP, we'll just refer to it like that. When you talk about a relationship, can you expand on what you mean by relationship, or maybe giving a simple example?
Yeah, the simplest example is the elliptic curve signature, that you have a public key and you have a private key, and public key is derived from the private key. This is a one simple relationship. And actually we can expand this relation into a arithmetic circuit, which is something like A plus B equals C and A times B equals C, something like that. Actually, and this summation and this multiplication, exactly what we are doing in the computer. So it means you can write some program and we can prove the input of the program is the output of the program you write. And that's the relationship that we would like to prove here.
Okay, great. So I don't know about you guys, but I feel like we've heard a lot about zero knowledge. It's been hyped up a lot in the news, or we hear about it on Twitter or just in discussions. What I'd love to know is it really a big deal? And if it is, why is it so important?
Yes, it is definitely a very big deal. I think I think as you can get an impression that like it is not a concept that it is easy to understand, but it definitely builds a very different different application, different computation paradigms that we haven't experienced yet before. And the current, like, if you watch the code, the research paper and published for this topic in this years, and the speed of topic, like month by month, like it is a very like people put a lot of money and efforts into researching this topic because it might solve some very deep problems that that frustrate us in current digital world. Yeah, so
That's really interesting. Can you touch on one, or because you mentioned earlier that it can do something that's not been done before, and it can solve some big problems that people are or developers are struggling with. Maybe one or two examples?
yeah, so I will start this example as a digital identity one. So as you know, you probably have some like identity card that say that has your names, that has your age, that has your genders, and you are kind of defined by a lot of these attributes. But a lot of application of this that requires only one or two of this attribute. For example, they want to the application might require you to prove you are a citizen of somewhere, but they don't require other attributes. And usually we are oversharing the other attributes in our daily lives, and that's why we don't have good privacy. But with the ZKP, we can prove that yes, this attribute comes from this identity card, and identity card belongs to you. So you can prove only the attributes that is relevant to the application setting, but without like revealing the other irrelevant detail that hurts our privacy.
That's a great point. You want to
Yeah.
add to it?
I'd like to add one more point here for about the scaling point too, because actually CC mentioned about the privacy that we can achieve through the ZK, but also if we have the zero knowledge, actually it means like you already proved the relationship. It means that you don't need to run that again. For example, what this is doing for the ZK VM is that making a proof that the state transition of the Ethereum block is correct, which means you don't need to run the re-execute all the transactions at all, because we have a proof which can be verified in a pretty fast proving time, a verification time. So actually ZK is also very matters in terms of the scaling too. So, yeah.
So interesting. So we were talking in terms of themes, it helps with privacy, it helps with scaling. Maybe we can touch on both of them a little bit. In terms of privacy, so earlier we were discussing about how, for the longest time, humans have always used, say, weapons, physical weapons to protect ourselves. But now we have a very different kind of environment to operate in, which is the digital world. And we need some weapons for that as well. So can we talk about how zero knowledge helps us to, how is it a digital weapon, as you guys said earlier?
Yeah, so to add a little bit here for about the digital weapon, actually, not only the zero knowledge is a digital weapon, cryptography itself is a digital weapon, and zero knowledge proofs, the recent improvements in zero knowledge proofs will let us use this weapon in a really, really easy way, regardless of the proving time and the verification time. So, yeah.
And why is it important to protect ourselves?
Because it's also related to the privacy, because I think I can introduce some store now and decrypt later strategy of the quantum computation. So some intelligent organizations are storing every data in the internet because they are based on their RSA signatures. And if we just store them into a storage for right now, maybe 10 or 20 or 30 years later, we're gonna have a quantum computer which can help us just decrypt the RSA, and then we can decrypt everything at the time. So that is a kind of a strategy. And also to protect ourselves from those kind of attack, we need a much better cryptography to protect ourselves for that. And this is how we are protecting ourselves from those kind of attacks. And this is why cryptography itself works as our own digital weapon in this digital world.
Sorry, just to jump into that a little bit more, what happens if we don't protect ourselves, or what could happen?
You're gonna give your own information.
Right.
Yeah, and also like that's without cryptography, like everything you see on the website, you cannot trust it. The thing, because we can trust the content you see on your mobile phone, is because the website is signed by a signature by the server, by the people who provide the content, and that kind of signature is managed by a certificate. That there's a identity management like organization, and that that kind of defines our current landscape of like internet browsing. And so as our life increasingly like interact with the digital contents, and like we are kind of shop online and like handling our bills and like bankings online, like we need more cryptography tools to make our online lives safe.
Yep. So it's also, it helps to differentiate, because it comes down to proving something is true. So it helps differentiate what is true and what could be a scam, maybe what cannot be trusted.
Yeah, that's true. Yeah, and especially when we think about scam, usually scam is trying to exploit the current loopholes in the current system that cryptography didn't defend you. So usually scammers' strategy can be summarized as like they try to learn more about you, they get more information about you, and the more information they get, they are more convincing to you, and then eventually you trust the scammer. So I think that's very important, like how do we control like our information to share, and that helps prevent scammers.
Great, thank you. Okay, so we'll just move on a little bit more into what's happening right now in the landscape. What are some important developments you think that's happening maybe in the past 12 months? What are developers working on? What are projects working on that you think is really interesting?
Okay. So one thing I see is the ZKML, the zero knowledge machine learning. It's still very early project, but I think one of the interesting application you can build is to prove that like Twitter used a certain algorithm to serve the content to you, because it's useless that people the Twitter publish their algorithm because you don't know if they actually use the algorithm to serve the content to you, but ZKML can prove to you that a certain tweet is ordered by that algorithm, and I think that helps increase the fairness and make the social media companies more accountable. And one of the researchers who's building ZKML is Kathy, who is also in this conference. And
Is she here in the room?
oh yeah,
Oh,
Kathy.
hey, Kathy. Interesting.
Yeah. So yeah, please talk to Kathy and like learn more about ZKML.
Great. I think, Kathy, you're speaking later. Yeah, okay. What time is your 11:30? If you want to learn more about ZKML, stick around, folks. Okay, any thoughts?
Yeah, also, I have a talk right after this discussion, and my talk is also related to the topics, what's happening in the recent ZK world. And just to share that here briefly, that we are going through more for about the programmable cryptography, not only for the zero knowledge proofs, but also handling the multi-party computations and etc. And also, we are going through, actually, there was a pretty big paradigm shift from the univariate polynomial to the multivariate polynomial that I will share in the talk later, which lets us prove something in a much faster compared to the univariate setup, which means, yeah, I mean, you can think like before that, to prove the ZK EVM, it takes like, how many hours does it take?
Maybe like 10 or more, like for for the current performance.
Yeah, it's kind of a maybe less than a day, right?
Yeah, almost. Yeah.
Yeah, but actually we should be able to do that in a kind of a millisecond or second. Yeah, this is what we have achieved in the recent progresses. And yeah, actually this is a really big shift. So we are trying to make everything provable in an easy way. So which means that our goal is something like you write some program and code and making it as provable to any kind of program, because now we see that, okay, it might be pretty feasible. Yeah.
And so the shortening of the time frame, so before used to be, you said, just under a day. Now we're making significant progress and proving is becoming very, very quick. So why is that so important? I mean, will it help for, say, user adoption of certain kinds of apps because, users don't want to wait so long? Maybe it makes it more expensive with the
Right.
previous hardware.
Let me give you some example. You are developing a racing game, simulation, Gran Turismo simulation game, and then you write every source code and people run the source code in your PlayStation and run that. Actually, that is not provable, but we can make it provable and it won't take that much time. So which means that if you run the program and provable, then you can prove that your Gran Turismo sim racing recorded kind of a 1 minute and 24 seconds, which is faster than Max Verstappen or something. I mean, yeah, this is possible. So people can write something, make it provable, and we can use it in many ways.
Interesting. Thank you. Earlier you mentioned ZK EVM. So I think I don't know if everyone's familiar with ZK EVMs, but it's been covered in the news a lot. We've seen big players like Polygon and Consensus introduce this. Maybe can we touch on that a little bit? What is ZK EVM and why is it so important? I think earlier we touched on, why zero knowledge is important. We talked about privacy. Maybe this is more towards scaling. So yeah. Can we break down what ZK EVM is and why it's important?
Yeah, sure. So don't be fooled by the ZK part in the ZK EVM. So it's actually a scaling project. It's not a privacy project. So as you might know, like when you interact with Ethereum, you actually if you send a transaction on Ethereum, you are actually running a computation on Ethereum. And that computation is performed by the every like 4 nodes. Like if you run the 4 nodes on your home, you process those computations and verify if the computations carried in the block is correct. But the current way your nodes do is to re-execute the computation. And that's very inefficient, and that limits the how many transactions, how many computations you can do on EVM. And so what ZK the ZK Snark ZK Proof can provide is we compress these computations into a cryptographic proof. So the idea is verifying the proof directly tell you the result of the computation, so you don't have to rerun the computation again. And that helps scaling, and that helps us to build some better light clients. For example, if you're using MetaMask or everything like that, you are trust the balance that Infura shows you. And if you can somehow validate that balance information, then you don't need that layer of trust. And there are other cool stuff you can build with ZK EVM. And for example, like you can build a proof of exploit that some of Grantee was exploring, which is when a hacker try to hack a contract and they could store $1 million, they don't have to do that. They can prove that they can do it and claim the bounty and fix the system. And like we can turn this black hat hacker into a white hat hacker. And that helps the system like become more safe. And yeah, finally, I want to cover that like ZK EVM is just one. It's just one part of a bigger set of ZK VM. Like the goal is trying to use ZKP to prove arbitrary computation, and which ones can cover more.
Yeah, I mean, right. So I just mentioned that our goal is prove everything. So we can, maybe the final goal is proving the computer itself. Maybe in the future, maybe we would like to prove the quantum computation too, because it's all about the mathematics polynomials. So because what we would like to do is just proving the relationships. And for right now, our goal, the next goal is making the computer itself as provable. And it's a easier subset of proving computer is proving a VM, which is subset of the computations. And the subset of the ZK VM is ZK EVM, and also which has a pretty good use case, just proving Ethereum change is correct. So yeah, this is about the ZK EVM and ZK VM.
So from computers to VMs to EVM.
Yeah.
So EVM stands for Ethereum Virtual Machine.
Right.
Okay, gotcha.
Yeah, because you know Ethereum is also a computer, world computer that we have only one in the world.
So ZK EVMs are like the first use case for proving a programmable blockchain, as we say.
Yeah, it's a very good starting point to try to prove making a computation provable. Yeah, because EVM is pretty simple set of some VM.
Okay, great. What could happen after we say we go through this use case of proving Ethereum? What could come next? What's bigger? What's better than that?
After the proving the ZK EVM.
Mm-hmm.
Yeah, that is the case. What I just mentioned, the Gran Turismo racing simulation game, the proving everything, every relationship.
Okay, great. We've talked about, what's happening right now in terms of ZK VMs is being discussed a lot. What else are developers working on? Like earlier we talked about, there's a lot of updates happening with developer tools because there's still some problems around that. So maybe you want to expand?
Yeah, okay. So yes, yeah, so the ZK space is still early, and we are lacking a lot of developer tools like and so far like current ZK applications you see in production are written in a language called Circom, which is short for circuit compiler, and in these years, we witnessed a lot of new proving system coming out. We have some like folding proof, we have like recursion proof, and we have lookups, which I covered yesterday. And Circon not yet can do like every of this. So we either need new language for that, we either need to extend the Circon for that. We also need like different kinds of tooling to improve the developer experience. For example, Zero-Knowledge14th built a very cool application that you can program Circon on a website. Like tools simple like this can greatly improve the life of the developers.
What was the name of that?
zkrepl.dev.
How do you spell that?
zkrepl.dev.
repl.dev. Okay, interesting. Any other, for the benefit of the audience, any projects that you think are cool or doing interesting things that maybe they'd like to follow as well? You want to share?
What?
Like interesting projects they're doing cool things, they're developing cool things besides, for example, ZK REPL.
Yeah, for example, I think Hello2 is also one. So
How do you spell that?
HALO.
Hello
Tool.
tool.
Yeah. So this is a tool built by Zcash. It is a tool we use to build the ZK EVM, and it was the tool not only available 2 years ago that can do lookups and we said the Plonkish proving system, and it needs more developments and more improvements. Yeah, because if you write Hello2 right now, you'll feel like so frustrating and so like it's not the best experience to write a circuit. Yeah.
Gotcha. What's up?
Yeah, so I mean, for right now, ZK itself is a very in the early days. Because of that, most of the dev toolings are does not have some good experience for you mostly. So because of the, and also the main reason is because all the proving systems and all the primitives are evolving and improving so fast. So every day, every month, we have a new POC, new minimum version of working. So because of that, the dev tooling experience is really bad for right now. So actually, we can think about that into types. For example, if you are just only focused on the applied applications, then maybe actually you can just try to use the Circom and like Halo 2, etc. But also, you might be also interested in contributing to deliver a much better depth links, right? And in that case, maybe actually recently, because we had a big paradigm shift from the univariate to the multivariate, so we are trying to make everything using some multivariate setup. And there are two very big libraries, which is something is a ArcWorks, and the other one is a ZK Crypto. And those two frameworks are kind of a base of the how to implement this multivariate stuff. And maybe if you can try to look at into that, maybe you might be able to contribute to the dev tooling experiences too.
Cool, thank you so much. Well, we're actually out of time. This has been very interesting. I hope everyone's knowledge is above zero, if it wasn't earlier, but we're gonna learn so much more for the rest of the day. If you wanna follow what they're up to, you can check out pse.dev website or Discord. And yeah, thank you so much for joining us. I hope you enjoy the rest of the day. And yeah, thank you.
Thank you. Bye-bye.
Thank you so much.